in general, solar production shouldn't be impacted unless we're talking about a non-export system. We mentioned like in California, they call it non-export or NEM3 or NBT, where the system needs to curtail if the battery is full and the customer doesn't need any solar power. So we're seeing situations where the solar has to stop performing because the battery's full and the customer doesn't need the energy and they're not allowed to sell the energy back to the utility grid. So you see scenarios like that. But where it gets complicated on the monitoring side depends on whether or not the battery and solar are AC coupled or DC coupled. So one of the things that we're seeing is a lot of the monitoring platforms are designed around reporting the AC output of an inverter. And in a AC coupled system, the battery's AC coupled to the home, solar is effectively AC coupled to the home. They each have their own inverters. So you can isolate, you can see this is how much PV is being produced or solar is being produced. This is how much the battery is charging and discharging. With a DC coupled system, when they're shared, a lot of the monitoring applications and the OEM APIs are set up so that you only see the energy that is being converted from DC to AC. So that means that it looks like the system is off if solar is going directly into the battery. So we see a lot of DC coupled systems where the energy endpoints and a lot of the APIs show that the system isn't on until noon, but that's just when the battery got full and it started pushing energy out of the inverter. In short, for an AC coupled system, you can isolate the solar and PV fairly easily. On a DC coupled system, solar performance monitoring gets complicated because you oftentimes have to find an endpoint in the API where you can isolate the DC solar output to confirm how much solar energy you're actually producing.